Okay, I asked you to do for homework from, I think you need a few more kinematics questions, numbers 1 to 4 on the back. I think most of you had finished number 5 in class, so I won't go over that one, but let's look at numbers 1 to 4. Oh, I don't know if I need to look at number 6. I think you all got it, so I don't think I have to. All right, so number 1 I had said was the toughest. So it says you're asked to start from rest, go a distance of 105 meters, and then end up at rest once again, all in minimum time. So you start here. You're going to go 105 meters out to here in minimum time. And it says your vehicle has a maximum acceleration and a maximum braking. So really what's happening is you're starting from rest, you're speeding up, speeding up, speeding up, speeding up, speeding up. And at the last possible second, you're going to slam on your brakes so that you will stop right at the 105 meter mark. Okay, so there's not going to be any part that's going to be constant speed. There's going to be a speeding up section and a slowing down section. And I purposely drew the speeding up one bigger because if you look, you'll see that the acceleration for speeding up is bigger than the slowing down. Okay, so it says you start from rest, VI is 0. You speed up at a rate of 7.5 meters per second squared. And your maximum braking, so your A2 in the second part, is -10. Sorry, I said you're speeding up is longer because your braking acceleration is bigger. I think I said that backwards up there. Okay, and then you have to stop, so your VF here is 0. Whatever the VF is in the first part, we don't know what it is, but whatever it is, it's going to become the VI of the second part. Right? And how are our delta D's connected? They're connected because delta D1 plus delta D2 has to equal 105 meters. Now what potentially makes this tougher than the others you've done is that we don't know anything about time, and for the first time VI's and VF's are here. So don't try to use the equation delta T is equal to VI delta T plus 1/2 A delta T squared, because then you're going to introduce a T1 for this section and a T2 for this section, which is really 2 more unknowns. Well, you already don't know D1 and D2 and VF, VI, so that's 3 unknowns. You don't really need 2 more. Instead, you want to get an expression for delta D to sub in here like we always have, but this time use your VF squared equation because there's no time in it and because you have the VFs and the VIs. So VF squared 1 will equal VI squared 1 plus 2A1 delta D1. Rearrange it for delta D1. VI squared goes to 0. So delta D1 is going to equal VF1 squared over 2A. And in a minute, we're going to take that and sub it in here. But let's do the second part first. So VF squared 2 is going to equal VI squared 2 plus 2A2 delta D2. Okay, this time the VF squared goes to 0. Rearranging for delta D2, then it'll be negative VI2 squared over 2A2. So, and we can sub this in here. So we're going to have VF1 squared over 2A1, keep track of your A's because they're different, plus a negative VI squared 2 over 2A2 is equal to 105 meters. But remember, the VF1 and the VI2 are the same. So this is really just V squared over 2A1 minus, because of that minus there, V squared over 2A2. Now sometimes people are like, won't this just be 0? Only if the A's are the same, and they're not. So now you need to solve for V. So I'd get rid of the denominator by multiplying by the common denominator. And the common denominator is going to be 2a1a2. That's the lowest common denominator. If you want to stick another 2 in there, 2a1, 2a2, it's also a common denominator, but not the lowest one. So multiply that by 2a1a2, or 2a1a2, multiply this one by 2a1a2, and multiply this by 2a1a2. Okay, now you might want to stop the video and try to finish this from here and then start the video after you have. Okay, so stop it now, try it, and then come back. All right, I'm going to keep going though. I don't need to stop the video. So that's going to cancel in this term. So I'll have a2v squared minus, and this one it's going to be 2 in the a2. So I'll have minus a1v squared is equal to 105 meters. Nothing cancels over here. 2a1a2. Trying to solve for v squared, it's in both terms. Factor it out. a2 minus a1 is equal to 105 meters over 2a1a2. Divide both sides. So v squared equals 105 meters 2a1a2 over a2 minus a1. Fill in your numbers. 105 meters times 2. A1 was 7.5 meters. A2 was negative 10, meters per second squared. Meters per second squared divided by negative 10 meters per second squared minus 7.5. No, don't go sneaky on me. The bottom's going to be negative, but it's okay because so's the top. Okay, and so when you do this, you get a v squared to be 900 meters squared per second squared. Take the square root. V is equal to 30 meters per second. Once you have this, then you can put it in up here. I have no clue what the question says. Determine t1, once the time. So once you have the speed, you can now determine the time. So for the first part, a1 is going to equal vf1 minus vi1 over delta t1. So delta t1, this is 0, is going to equal vf1 over a1, 30 meters per second over, what was it, 7.5 meters per second squared. Delta t1 should be 4 seconds. Do the same, my box is moving. Do the same for t2. So a2 will equal vf2 minus vi2 over delta t2. So delta t2 will equal, the vf2 is 0, negative 30 meters per second over negative 10 meters per second squared. Delta t2 is going to equal 3 seconds. I don't think the question asked, but if you want it, you could determine the time solution, determine, and then it doesn't ask you to find the distances, but now that you have everything else, you can just stick the stuff in and find the distances if you so desire. Okay, so just a little, like, same idea. The only thing that I thought might complicate your life was you needed to realize, don't use the delta D equation with the times, use the one with the VF squared, so you're not introducing another set of unknowns. All right, number 2. The toughest part about number 2 was reading it. It goes on and on about falling from the roof. You should picture yourself falling from the height. So you're falling. VI is 0. From a height, you're falling, gravity is 9.81 meters per second squared. You should put yourself falling from that height face first onto the hard floor, because it's essentially what will happen if you get in a crash without a seatbelt. Car will smash into whatever it's colliding with. Your body, meanwhile, having nothing to restrain it, will continue to move 56 kilometers per hour. Find the height you would have to fall from to hit the floor at that speed. So your VF is going to be 56 kilometers per hour, and you want your delta D. The only thing you have to do here is VF squared is equal to VI squared plus 2A delta D, and rearrange for delta D. So VF squared, this goes to 0 over 2A. So 56 kilometers per hour, when you switch it to meters per second, is 15.5 repeating. Square it. Divide it by 2 times 9.81 meters per second squared. Okay, and you should get a delta D of 12.33